So now that we have the correctly formatted CSV files to use in pMAT, let's go ahead and do that. The goal of these videos is not a tutorial of how to use pMAT. It is to show what Plexon data look like after analysis in pMAT. And I will also touch on a couple features that I liked or had difficulties with. So I'm using pMAT as the independent application because I do not have a MATLAB license on this computer. So this is actually a feature that I really liked in that you could use it separate from MATLAB. So this is what the pMAT independent application looks like right after you open it. And the first thing you need to do is import your data. So hopefully this was just me, but I could not find the import CSV data function the first time I opened this up. Thankfully, the Barker Lab and the authors of pMAT had a very helpful YouTube video tutorial and pointed out that the import data button is up here in the upper left-hand corner. So it's actually a drop-down menu and it's the only thing up here, which I think is why I had such a hard time finding it. But once you find it, you simply import your CSV files. It's going to ask you first to open your recording file. And so you can see that up here in the upper left-hand corner of this file window. Okay, so we're selecting the fiber photometry data that we've already formatted. So interestingly, it's going to come up with another pop-up window here that's going to ask us how many samples at the beginning of the file and end of the file we want to remove. So GuPPY also has this feature, and both programs were created using TDT fiber photometry data. And so I believe this is a carryover from that type of file. However, I'm lucky that this has it because in our particular file, the recording was started before the LEDs were turned on. So I actually need to remove the first 1,713 data points and nothing at the end. Then it's going to ask us to open the event or behavioral TTL file, and very nicely it opens right back up into the same folder that we told it had our fiber photometry data. So now the data are loaded and you can see the path to those data up here in this white box. One of the nice things about pMAT is you can do all these different functions separately. So you can plot and trace your full data separate from the event histograms if all you want to do is look at it. So I'm just going to do one graph, which are the normalized isosbestic control data. So this is a z-score done after the data were isosbestic corrected. And I'm just going to have it also plot the air puff event. So we just give it a second here. And it pops up with this graph. And it will also pop up with a note here in a second that this figure has been saved. So pMAT automatically saves all the figures that you tell it to show you, and it will save it in that same folder where you said the data was. So here's the folder up here where I told it where the data was. Here's that data, and it created a new folder called figures, and in that folder we can see that figure that it just showed us. It's in a JPEG file and also a matlab.fig file format, so in case you do have MATLAB, you can look at these in MATLAB. So it's a very nice figure, and we will just move right along. The next thing I want to show you is the peri-event histogram. So this, you can select whatever event you want, again if you're importing more events. And you can name it something else if your event wasn't a descriptive name. I I've looked at these data, so I already know the time that I want to look at. And I'm also just going to do a 1 second baseline. Bin constant is something you can play with. This is how many points of data do you want to bin together. So for something like TDT data, which is collected at just over 1,000 hertz, binning 100 of those data points into one point is reasonable. However, with Plexon data, which was collected at 30 hertz, that's maybe not the best way to go. So I'm going to show you what it looks like with one. So essentially that's no binning. And I'm going to do another one and show you a bin of 5. So I want to print out the z-scored per-event histogram data, and then I'm also going to export some of the data. And so here it pulled up the figure. On the top we have our heat map, and on the bottom we have that average line graph. So I don't know about you, but the first thing that I see when I open this graph is, oh my gosh, there's no color bar. I have no idea the scale on that heat map. But in these MATLAB figures, what you can do is you click on the part of the figure that is the heat map, and you'll see you've clicked on it because these little tools come up in the upper right hand corner. And then on the toolbar on the very top, there's a shaded bar up here that looks maybe like a little color bar, and it will insert a color bar. And then you can right click on the color bar and change your color map if that is something that you are interested in doing. So again, this figure was automatically saved. And let me show you what it looks like now with a bin constant of 5. So you get the same heat map and line graph, but it doesn't look as smooth. And again, this is because you took 5 data points and averaged them into one data point. Another thing I want to point out is that it automatically saved those 2 figures, but it didn't save over one or the other. So here we see the z-scored per-event histogram and the per-event histogram 1. So every time you do the analysis, it will resave the figure without saving over the previous one, which is really nice. Additionally, back in our original pMAT formatted data folder, we see another folder was created called data. And in that file are CSV files of those per-event histogram data. And again, these don't write over each other. A new file is created every time the analysis is done. So in summary, pMAT is very easy to use, and the only issue I had was finding that import option for CSV files, which hopefully you won't have an issue with. So I highly recommend pMAT, especially if you're a beginner or need to quickly convert the raw numbers into a useful graph. So if you are interested, please stick around for parts 3 and 4 of this video, where we go over use of Plexon multi-wavelength photometry data in GuPPY.